Hey guys, Cam back here in the Battler Workshop and welcome. Well, it's very cold. We're in the winter at the moment. It's about 8 or 9 degrees outside. It's been pouring rain. Absolutely freezing cold. We've got the potbelly stove on, and we've been doing a few little jobs in the shop. The biggest one I've just finished recently is the Victor Lathe pulley drive and brake drum assembly. So we've got that all back together and the lathe is now running again. I had to do some modifications to that. There had been some gremlins at that some time before, so we've had to fix up some major alignment issues both on the belts and also on the brake band. So we've got them all sorted out. I'm very happy. The new drive's up and running, and very happy with that as well. Also in this video I've tacked into this a fire hole door that I made up for a Heidi locomotive that my brother is currently fabricating. So he's fabricating the boiler for that in duplex stainless again. So the customer asked if we could do a fire hole door for him, so Andy's designed it and I fabricated it. And also at the end of this video you'll see a gift that I made for my wife Rosemary, and she did remind me it was 28 years ago it got damaged when we moved here. And so it's been sitting in a cupboard for 28 years, and I finally got it out and did the repair on it. It was a gift that I made for her when she was my fiance on her 20th birthday. So a long time ago. So she's very happy to see it out in the living room again on the buffet and displayed. So yeah, sorry about that sweetheart, but we got there in the end after 28 years. Alright guys, enjoy the video and we will see you soon. Cheers for now. Alright guys, trying to pick up from where we were. I've machined all the components for the brake drum and the pulley set for the new motor that's going to go on the Victor Lathe. This is the old brake drum pulley set that came off. This is cast iron. I've created a few chips on this. This took an awful lot of work to get this off. It was an absolute pain actually. The main reason I've had to make up the new pulley set and new brake drum set is that the old motor, which was a 2-pole motor, 4-pole, 8-pole, had a 32mm shaft on it. The new motor I've got, which is a 4-pole, is 38mm in diameter, so quite a difference. If I machined this out, I wasn't going to have an awful lot of meat left on there, so I decided I'll make up a new one. You might recall on the previous video I showed me trying to slot in a dummy blank the keyway for this, and you saw the tool get totally jammed up. And I'll just flick a quick video up and some photos of that slotting action in that dummy blank just to see how this was going to work out. We're certainly getting some nice chips out the bottom. Oh, that's not good. Now, as you saw, there was an awful lot of flex in that small 1-inch square bar, slide bar. So, okay for the shorter stuff, maybe up to 50mm, but coming out to 70mm, a bit too much of a stretch. So, as I mentioned, I sent this off to one of the contractors who used to do a lot of work for me in a previous life. And they broached the keys in for me because I'd never have a 10mm broach. Alright, so as I said, it's a 2-part because of the length of the keyway. So we have a registering face on here, which is where the pulley is going to engage into. What I've done is I've drilled and tapped, or drilled through and tapped 6 M8 threads to lock these two together, and I put a key in the keys to align them, lock them up, and drilled and tapped those, or drilled those through and then tapped them out, and that's come up quite good. So all the socket cap screws that are going to go into that. The other thing I've done is I put a couple of M12 threaded holes in here so that if this ever has to come off again, I can set a strong back up to pull that off. There was nothing on here. I had to do this with wedges and just work and work and work. It was a couple of hours trying to get that off, so I don't want to ever go through that again. This unit here is a a hand push on and a hand tap on fit. Now you'll see that in a little while. Alright, let's head down to the motor and we'll have a look at how this is going to fit up and how it's going to look. I'm going to get this on first. I'm going to leave the screws loose until they get on. When I did machine this, or do the final machining on this, I made up a mandrel so that everything was dead concentric, and I did a lick over the entire outer surfaces just to try and minimise any out of balance issues. Alright, let's head down to the motor and we'll have a look and we'll start getting this back together. Alright, at this stage I've only done those socket cap screws up loose because I want it to align onto the shaft. Once the two sections are aligned onto the shaft, we'll knit them up nice and tight. Alright, so I've gone around a number of times with the Allen key and I've given that a good thump with the hammer to make sure that that is locked up nice and tight. So I'm hoping now that that's still going to slide. Oh yeah. Probably about 4mm left to go. That's it. Alright, I've just got a grub screw in there for the key, so I'll just nip that up. So I've got about 10th hour clearance from the top of the key to the underside of the slot. Alright, I think that's ready to go back in now. Hopefully all our measurements have panned out correctly, and we're going to have the V-belts pretty spot on and the belt pretty well aligned as well. Alright, now I'm going to have to wrangle this into the motor housing cavity under the lathe. So I'm going to set up my overhead crane and we'll get that wheel into place. Now it's been a while with this motor, so this motor has a 132S frame, which means that the centre distance on the bolt holes is shorter than the centre distance on the old motor. So this is a 132M frame. The distance between the centres across the front is identical. It's just that this has a longer foot, being a larger frame motor to suit the 4-pole and 8-pole configuration. So that's why I've re-drilled the base plate. You would have seen that in one of the other previous videos where I set that up on the mill to get that pretty spot on. Alright, I'm going to manhandle this into position off camera because it's going to be fairly awkward and all you're going to see is the back of my noggin. So we'll get that into place now. Alright, I've just slotted out these holes. I've gone 4.5mm. That should be plenty for us to get those belts aligned. I'm just taking this apart, and this is the anchor for the band brake. It is threaded into here. I didn't think it was. So what I'm going to do is make up a little spacer that'll slide in onto that thread. Sits on this side here, and that'll push that band brake anchor across. And I think we should be pretty right then. Well, I'll get that little bush made up, or that little spacer made up, and we'll get this back into the lathe, and we'll get everything lined up, and we'll see how we're looking. And that's the motor from the back end. So you can see that band is sitting pretty plumb central on that drum now. And as I said, the belts are dead plumb too. So a bit of work to get it right, but I'm happy that it's done. Alright guys, we're finally getting everything back together now. The brake band was out an awful lot to get it central onto the brake drum. The pulleys were also out an awful lot, hence we did that slotting of about 4.5 mil on the base plate. The belts are now dead plumb from top to bottom, so I'm happy about that. And I've also made a change to the fork assembly for the brake drum band. So you can see that tapped hole there. Where that tapped hole is where I had to drill out a taper pin, and that was a huge saga in itself trying to get access into there to do that, but I've managed to get it out, and I've drilled it out and tapped it for an M10. And I've made up this little spigoted cap screw. It might be a bit hard to see, but I've actually drilled into that hole, into that shaft with that little spigot. So it's actually allowing that shaft to be in a shear plane on that pin now, so I'm not just relying on the friction. I still have that other little cap screw there that's in there, which is just pushing down on the shaft, but where that threaded hole is now, I now have a positive engagement. Alright, so it's done up nice and tight now. Yes, that motor was out an awful long way on those belts, so everything's trued up. It's hard to see, but you can see the brake band is pretty much dead plumb onto the drum now, whereas before it was angulated very terribly and it was riding up on those tapers. Alright, let's get the whole thing boxed up and get this lathe back into action. So you can hear that limit switch coming on just as the band brake engages, so that's all good. Alright, so that's the belts all back on again. I've just got the large gear sets to go back onto that quadrant plate now, and that's sorted out. Alright, next little job I'm going to do, this is the old controller off the old VFD that blew up on me. This is the new controller, and that's the potentiometer, the pot that I use for the speed control. I'm just going to change this arrangement on this face mounting a little bit differently. I'm going to put the speed pot on this side here and remount the controller into that spot there. A little bit easier to get at with the DRO over the top of it there. So I'll rearrange all that, make that a lot neater. Alright, so that's everything mounted up. So we've got the main controller programmer panel, which I've remotely mounted from the VFD. We've got our speed control pot, which I've programmed into the VFD as an external source. And let's kick it off and have a listen to it. And the foot brake. So everything's functioning beautifully. Very happy with it now. Well, I'll show you a little change I've made over the back there. I was concerned about chips flying over the back and into the fan motor aperture and then into the electronics and causing an issue. So I'll show you what I've done there with a little 3D printed guard that I've made up. So that's the little guard I've made up. It's just 3D printed, something fairly simple, nothing flashy. I'm just going to use a couple of self tappers to get that positioned into shape, but it protects that fan aperture that you can see inside there from chips flying over. That's the last thing I wanted, is to have this thing this thing blowing up as well. But that's it mounted all in place, all wired in. Just got to put it back into the clips, but yeah, it's complete, so very happy with it all. Alright guys, let's leave it for now, and I'll see you guys on the next video. Okay, another little job I've just finished for a Heidi boiler that my brother is currently fabricating. Well, it's almost finished. I did all the machining on that boiler, and he's done all the welding. Well, he's designed it and done all the welding and done a beautiful job of it too. But the customer asked if we could do a fire hole door for the boiler. So Andy's designed it, and I fabricated it. So this is all out of 316 stainless. Got the pivots there. These pivots need to be welded onto the boiler, as well as the latch, or the catch needs to be welded onto the boiler as well. Got a little handle that pivots. A lot of intricate work in this, a lot of rotary table work in this, particularly to shape up the hinges. You can see they're actually offset hinges. And you can see the recess we've cut for that to allow to sit into the fire hole. Got a nice little kick on the latch handle. So as I said, all our 316, and I'm very, very happy how that's come up. I think the customer is going to be really pleased with that. It certainly looks good. All right, so that's just a little job I've done on the side, and that's now complete and ready to go. Okay, the next little item is an item that I repaired. I made this for Rosemary when she was my fiance back in 1985, I think we'll see there. And this got damaged in our move to our current home about 23, 24 years ago, and I've only just repaired it. The piano got smashed off its support there. The lids had come off, and it was a bit of a mess, and it sort of sat away in a cupboard unrepaired, and I finally got it out and spent a day repairing it and putting it all back together again. So it's a lot more robust than what it was when I first did it back then. Now, this is based on a piano that when I first started going out with Rosemary, the first thing I noticed in her home was this beautiful upright piano in their living room. And Rosemary's mum, Margaret, not only used to play, but she was a very, very good teacher. And Les, her father, played the bagpipes very, very well. And that's how he met Margaret, because she also played bagpipes, and they met in a competition. Les also played the saw, and it was wonderful to see Margaret and Les together, Margaret on the piano and Les on the saw, and they put out a beautiful tune when they were playing together. And I'll just make a little note. You can see the scroll work that I put inside there, and I did that with wax etching, scratching in the shape after I transferred off some tracing paper, and I etched that in with nitric acid. Now, the nitric acid I got from a company in Geelong called James Officer. Downstairs they had floor coverings and carpets, and upstairs they had a chemical section, and I bought a litre of nitric acid and took it home on the bus. You could imagine these days what you would have to go through to get a litre of nitric acid. So the whole piano is done out of bronze, and the keyboard and the seat you can see there in the silver colours, that's pewter. The timber is blackwood, and the ornate posts I did in brass. And the glass I got from a laboratory supplier in South Melbourne. It's about 4 mil thick, actually. It's really, really thick glass. Anyway, that was just a little job I did after 23, 24 years of it being damaged. I finally got around to doing the repair, so it's got pride of place now back on one of the on the wall unit we have. All right, guys, just a little update on what's been happening in the shop, and we'll see you soon. Cheers for now.